All right, guys. I know another video, sorry, but I did want to make sure that you all were able to get this lesson. And we've actually done quite a bit of this before. We're doing isosceles triangles in this lesson. Don't forget about page 48 and 49. It will be due on Monday. We are now not having a county formative on Tuesday. We're actually changing that to an activity. We will not be having our county formative on Tuesday, but rather an activity. For your warm-up today, you are given that MR is equal to 104. So this whole segment is 104 centimeters. NQ is 6x minus 2. And NS is 5x plus 3. And you're going to find all of the different indicated measures and think about the theorems that you are applying during this process. So this is just a bigger picture of what you see. Go ahead and pause the video here and start looking at solving this. And when you unpause, you will be able to see the answers for your warm-up. And we'll go through it. All right, so again, thinking about this, we have that NS is 5x plus 3, and NQ is 6x minus 2. Remember that NQ is half of 104, so we know that NQ is 52 centimeters. Therefore, we can set 6x minus 2 equal to 54 centimeters and solve that and get x equals 9. Once we get that x equals 9, we can then plug in and know that PR is double NS. So we have one of two ways of doing this. We can just set an expression. So PR is 2 times 5x plus 3. So PR is 10x plus 6. Substitute a 9 in, and we get that PR is 96. Remember yesterday we talked about the triangle midsegment theorem, which says that the midsegment of a triangle is parallel to the non-adjacent side and is also half its length. All right, so this is if you, oh, we're not there yet, we're not doing that. We have sides and angles of triangles. So in this case, we know that the shortest side is going to be opposite of the smallest interior angle, and the longest side is opposite the largest interior angle. We kind of talked about this yesterday when we said that, remember, if we have two sides that are congruent in a triangle, we were talking about isosceles triangle, that we know that the angles that are opposite of those are also congruent. So this is kind of the same idea. However, we know that if this is the smallest angle, that the side opposite is the smallest side, hence the 14.8 being the smallest. And then if we look at the largest angle, we know that the side opposite is the longest side. And actually vice versa, that also works. So opposite of the largest side is the largest angle, opposite of the smallest side is the smallest angle. All right, so isosceles triangle theorem. We did already prove this and go through the isosceles triangle theorem I think it was last week. So we did this together. So just kind of keep this in mind as we go through and we make these applications. So in this case, if I know that this angle is 75, then I know here that x is also 75 degrees because it's opposite the congruent side. So if this is congruent and this is congruent, the angles opposite of them are also congruent. Here, I know that this is 30 degrees, which means that this is angle x and this is angle x. So I could say x plus 30 is equal to 180, which then 2x plus 30 is equal to 180 using triangle sum. Subtract 30, 2x equals 150, divide by 2, and you know that each of those base angles is 75 degrees. Okay? So I'd like you to go ahead and try number 3 and number 4 and number 5 and number 6. Actually, I think most of these you should be able to do pretty easily. You're either going to be subtracting the known angle and dividing by 2, or you're going to be setting it congruent to the angle that you know. So you can go ahead and get started on that. All right, so if you were working on this and you had a chance to do some of these, we're going to go through them really quickly. So we know in this triangle again, that the formula would be 2x plus 98 is equal to 180. So if I solve this for x, I would get that x was 41 degrees. Over here, it's the same situation. Well, actually, not the same situation. This is the angle that I'm looking for this time, which is the what we call the vertex angle. It's the non-congruent angle in an isosceles triangle. So I can say that 86 degrees plus x is equal to 180. Then I can subtract 86 from both sides and get that x is 94 degrees. Okay, this is a scenario very similar to that one that we just talked about. So I know that this is 54 degrees, which gives me that x is 72 degrees. Over here, this is a scenario like we talked about in number 2. So I'm going to say 2x plus 50 equals 180. And then subtract 50 and divide by 2. And I'm going to get that x is, let's see, what is that, 65, I believe. And down here, this is the one where this is both 51. So add them and subtract from 180. I get that x is 78. For this one, same deal. I get that x is 114, I think. Yep, 114. And last but not least, again, 2x plus 38 equals 180. So you're going to do 180 minus 38 and divide by 2. And you should get 71. All right. Next, let's go ahead over to the isosceles triangle application. So use what you know about triangles to find the value of A. Find the measures of x, y, z, and describe triangle x, y, z. Okay? So go ahead and talk about, or start looking at this one. All right, so we know that this is a equilateral triangle because all of these angles are congruent. So we have a 60, and a 60 here. We know that this is A degrees, which this is also A degrees because these two triangles are congruent. Again, I know that they're congruent because this side is congruent to this side, so therefore I have angle, side. So I could say that triangle, or this, I guess this isn't named. So whatever this point named, triangle XY, this center point here, and triangle ZY and this center point, these two triangles are congruent. So if those two triangles are congruent, then I can make up all of these angles add up to 360. So I'm going to say 60 plus A is equal to 360. Subtract 60 from both sides. 2A equals 300, which means A is equal to 150 degrees. So therefore, I know that these A's are 150, which means then I can find X and X here. So I'm going to say 2X plus the A degrees, which is 150, equals 180, which means 2X equals 30, which means X equals 15. So therefore, I can say here that if this is 15, then I know I could use angle sum to then find the bigger angles as well. Okay. All right. Let's go on. So here, this is the converse of the isosceles triangle theorem, which that if I have a triangle where the angles are congruent, then I know that the sides opposite are congruent. And again, it's really just the reverse idea of what we talked about in the other isosceles triangle theorem. And now you're going to use the isosceles triangle theorem to find all of these missing sides in these kind of compound figures. So just to kind of start you out here with number 11, which this is on page 52 of your packet. So if you want to flip over to page 52 now. Okay, we know that this angle is 148 here. We know that this is a 90-degree angle right here. Okay, which means we could technically find the other angles. We know that this side is congruent to this side right here. And we know that this side is congruent to this side right here. One thing you need to know is that figures are never drawn to scale. So if I know that these two angles add up to 180, I know that that angle is going to be 180 degrees minus 148 degrees. So if I do that, I'm going to get that that angle is 32 degrees, which leaves me two angles here and here that are congruent. So thinking about that practice we just did, 2x plus 32 equals 180. Subtract 32 from both sides. 2x equals 148, and divide in half. So x equals 74. So I know that those two angles are 74. Again, I know that this angle here is 90 degrees, which if this one's 32, then I can find this one by doing 90 minus 32. 90 minus 32 is 58 degrees, which since this side is congruent to this side, I know that these are both 58 degrees here and here, which then allows me to find this angle, which we'll call y. Actually, I shouldn't have called that x, I guess, should I? I should have called that a different letter because I already have an x in this figure. So why don't I just call it z? I'll call it a z. How about that? So z. Okay. So z is 74. These are both 58. So I'm going to say 58 plus 58 plus y equals 180. Add those together, I get 116 plus y equals 180. So y is going to be equal to 64. So if this one's 64 degrees right here, actually, why don't I just do this? That would look a little neater. This is 64 here. In order to find x, I know that these two are supplementary. So x is going to be 180 minus 58. So x is, let's see, 122 degrees. Okay, so you're going to work these out. When you are finished, the sub will have the answers available for you to look at by the end of class. And then there is an optional homework that is on page 54. If you would like to complete that optional homework, you can practice this a little bit more to make sure you're good. The activity we are having next Tuesday is going to be an assessment-based activity. We're just not doing the counting formative, and it will include mid, segments, and isosceles triangle theorem. So good luck, and let me know if you have any questions.